Welcome back everyone to the CAS seminars. I would like to also welcome you who join us from Zoom. Welcome. And today we're very excited to have Professor Kockelman joining us today. Dr. Kockelman is a registered professional engineer and holds a doctorate, master's, and bachelor's in civil engineering, a master in city planning, and a minor in economics from the University of California, Berkeley. She has been a professor of transportation engineering at the University of Texas at Austin for 23 years. Her primary research interests include planning for the shared and autonomous vehicle system, the statistical modeling of urban systems, energy and climate issues, the economic impacts of transportation policies, and crash insurance and its consequences. And today, Dr. Kockelman will talk about self-driving and all-electric, anticipating the travels and energy impacts of autonomous vehicles in US markets. And without further ado, please join me to welcome Dr. Kockelman. And Dr. Kockelman, you may start your presentation.
Thank you. Thank you so much. This is really exciting for me. I've enjoyed talking to some of the faculty earlier today, and we'll be speaking with them afterwards. So I hope you can hear me all right. I wanted to present 4 very different papers about self-driving and all electric vehicles because these are coming. And of course, we all really hope that everybody electrifies their travel as quickly as possible to try to protect this planet from grossly overheating. Although I'm sure those of you in a cold Urbana-Champaign location may long for warmer days. So the first paper is about looking at all of the travel changes that might occur in both for passenger and freight across the mega region of the Texas Triangle. So that's Austin in between San Antonio, Houston, and the Dallas-Fort Worth Metroplex. And we have a statewide model here in Texas, so we do have a lot of traffic analysis zones for that. And this triangle contains, almost half of those. Even though it's not a large share of the number of counties, they are the state's most populous counties. And it's tens of thousands of roadway links. And we modeled the wider system, so Texas and its travel and trade with other states, and then extracted the triangle from that to get a sense so that we didn't have much of a halo or a boundary effect on the travel demand predictions.
She doesn't look young. She's pretty.
So if you could mute anybody who's in that box there, that'd be great. So like many of you have learned about the 4-step travel demand model, when you're trying to simulate a big system and there's freight going on and not just passenger travel, a 4-step's not a bad way to go because it is a very large system and takes a long time for some of those long distance trips to complete. But it does capture local trips as well as long distance, which is important for us here. And we have that business as usual case. So BAU is if we didn't have AVs in the future. And here it's not just privately owned autonomous vehicles, but shared autonomous vehicle fleets, which is what the manufacturers plan to do first, because they don't really want you or me trying to maintain an autonomous vehicle and placing them liable for any dirty sensors or things like that that might cause a crash, or not rebooting the computer. And so the shared fleets offer them more protection as they kind of learn about this technology. And it also makes better use of the vehicle, since you and I only use our vehicles about an hour a day on average. There's also autonomous trucking, of course, that's competing pretty well with rail and maybe with air and water. And so we've got these different scenarios to before and after the autonomous vehicle is really mature and has been made fully available across the state and across other states. So we're tracking trade throughout the continental US. And we do try different parameter assumptions in the paper. I'm only going to show you the standard assumptions, but 4-step model is pretty typical, and we're doing a 1-day run. And so we assume that the human-driven vehicles cost about 60 cents a mile for their total operating costs. So that's with insurance and registration and everything. And the autonomous vehicles in this particular scenario, we place them at 80 cents per mile. And of course, you can fill those vehicles with up to 4 people, maybe 5 people. And if you share them, you might have control of the vehicle at $1 per mile. So if you own the autonomous vehicle, it's a little bit less expensive, but of course you have the headache of having to store it and maintain it. Whereas if you just rent it when you need it, all those headaches go away. And the value of time is lower in the case where you don't have to drive the vehicle. So if you're being chauffeured by the vehicle, you're less worried about time because you can focus on other things. And so even though it may cost more in terms of money for that special technology, it is cheaper in terms of your time, and you're willing to spend more time on the road because you can look at your phone or sleep. And so, as you can imagine, the automobile use rises because not only do you have access to the conventional human-driven vehicles, but you've got access to those self-driving and shared self-driving vehicles. And the Texas airport markets for within Texas flights fall dramatically, like 85%. Bus and rail, and of course, rail is really for freight in this country, unlike other countries where it's more for passenger, but both of these are falling once the autonomous vehicles are introduced in the freight and the passenger markets. And if we're looking at trip distances just up to 50 miles of distance one way, you're seeing automobiles, being rising quite a bit, especially in the 5 to 10 or 5 to 20 mile distance market, whereas you've got small reductions across rail. This is, in this case, a passenger rail, which is already a very small market, as you can imagine, in Texas, and the bus. And the bus, of course, is generally not for long distance trips in terms of the number of passenger trips, but there's, maybe a fair number of miles within that mode. And if you look at the longer distances, so we're going out here to about 400 miles of distance, now air starts to play a role, and a lot of these triangle, so this is just the triangle as air market. So it's not Europe. Of course, you're not going to take an autonomous ground-based vehicle to Europe. So this is just within Texas here. You're seeing the 150-mile distance trip, which is pretty much what you get between Houston and Dallas and San Antonio. There's you see a big hit to the market there, big difference. And if you look at the freights, you can see that some of these commodities have a big change from the base case, a big reduction. A big percentage reduction happens in coal. So that's kind of interesting. Coal is a very big product for our rail lines to move from Wyoming, where it's relatively low in sulfur, still not a healthy feedstock for our power plants, but across the rest of the nation, especially Western US. And then chemicals, also another relatively big increase for the truck mode, picking those up because it is cheaper, especially for the long haul. So a lot of businesses will keep a driver in the vehicle. He or she may not be a driver. They may be more of a manager and doing administrative tasks. So it's not like you can completely eliminate humans on board these expensive assets, these trucks, but it does allow the vehicle to go a lot further because whoever's on board can sleep and do other things. And so they won't be probably subject to the hours of service rules that we have right now. Chemicals, petroleum, clay also seem to have reasonably big increases, but really in terms of percentage increase, maybe 11% for the truck mode on the chemical and 50% on the coal. So those are big. You can look at trip distributions across all these different modes. This is passenger travel, automobile, as a total, because automobile includes those autonomous and and shared autonomous vehicles, does go up. And, there are big markets between the big cities. So you can see some bumps in these longer distances as you leave the region of about 50 miles, 70 miles distance, and you go out to 370 miles here. So automobile definitely seeing a big increase, even though it is more expensive in terms of pure dollar cost. It saves you a lot of time. And so we're seeing trip distances going up from 14 to maybe 16 miles, and freight spatial patterns shifting. So this is the triangle in gray here. This is Houston region. And, you can look at whatever commodity is of interest and before and after those autonomous trucks are introduced. So about a 9% increase for the truck, or 100 million or more ton mile increase. And it really depends on the market, really depends on the commodity. So you can, get a sense. These are all county to county maps of the heaviest flows to get a sense. And the vehicle miles traveled rising dramatically, more than I would have expected. So almost 50%, with the air falling by like 85%. So that is huge for the local carriers, like a Southwest Airlines in terms of its Texas market. And the Austin region, heavier, in fact, so maybe more than a 50% increase on the roadways in our 6-county region here. Once you fully automate, that you make this, you achieve these prices. So there's still people who are allowed to maybe take a human-driven vehicle. I do think that will disappear in the future. I don't think it will be ethical to allow people to drive around with a human at the wheel, except maybe on Sunday mornings. And of course, we will allow them to go rent time at a racetrack if they want to drive themselves. But just like horses, I do think we will get them off of the road. And at that point, maybe some of this VMT will fall because you can't drive yourself, or maybe it'll go up even further once we remove that mode. So there's a fair amount of congestion after the AVs. There's some before these autonomous vehicles, of course, in these big cities. And so like 92% of the links end up with higher flows across this network. And so you've got almost 10% of your links with, current sort of land use patterns. If we were to introduce autonomous vehicles and make it an available technology, we would see almost 10% versus about 5% of the links having a volume to capacity ratio above 1. So demand exceeding supply. And like I mentioned earlier, an increase in trip distances for the passengers and also for the trucks, I'm sure, and air travel falling dramatically, and VMT rising more than I would have expected. So my expectation is maybe 25%, but here in the Austin region, we were seeing it even past 50% for this kind of modeling. So other models that we do, like long distance passenger travel, how that's affected. So this was really focused on passenger travels across the US and beyond, and another look at airline revenues. And we started with these coarser zones that are mostly built on the counties across the nation. We have about 3,300 counties, or 4,500 microdata area zones, NUMAs, they call them. And FHWA back in like 2015 paid RSG to synthesize or fake basically long distance trips for all 310 million Americans back then. So it's about 117 million households, and it generated a lot of data, destinations, departure days, mode, how many people in the travel party, trip purpose, all these kinds of things. And so we were able to use that, even though at this point it's 11 years old. We published this paper a couple years ago, and this gives you a sense. So in the case of air travel, the heaviest, we see a lot of air travel going through or to Atlanta. This is for work purpose in this particular example. And of course, these trips go beyond. They go beyond the US, and this is just a spider map for the continental US. So we added the autonomous vehicle mode there, just like we did with Texas, using a nested load specification again, but we focused on passenger travel, and we only focused on trips over 50 miles of length one way. So it wasn't the same as the Texas look. And of course, a much bigger playing field now, much bigger setting, sort of global look at long distance travel. And we have to, keep track of airline frequency and all these things. And we're cognizant of the fact that the faked data that RSG created for the FHWA was hard to match. Their models were numerous and overly complicated, I think. So we pivoted off them. And just like with the previous model, we assumed a marginal cost for these trips. So we assumed people already owned a vehicle, and that the marginal cost of using that vehicle might be 17 cents a mile with a value of time of $12 per hour per person. And then the autonomous vehicles would cost more to acquire, but they would save you a lot of value of time because you don't have to drive that vehicle. what you're seeing here is the original data and those 4 modes. This is a log scale, so bus is certainly not that high if you were to have a standard scale. So car is, maybe 100 to 1, so 2 orders of magnitude bigger than the bus, and rail. And air really starts to dominate after 500 miles of distance. And of course, after 2,000 miles of distance is really only the car and the air modes that have a role. And of course, once you hit the ocean, I don't think the car is going to really serve you very well. So air is practically the only mode going, transcontinental. And once we added in the AVs, then we added in this 5th mode for these long distance passenger trips. And we're not showing you, I guess, the shortest bins. Air, of course, doesn't really play much of a role until you get to about 150 miles of distance. And so these bands are starting at the 500 mark, which is where air really starts to dominate in the traditional setting. But now the autonomous vehicles are picking up a very big share. They're competing very healthy with the human-driven vehicles. So some people will hang on to their human-driven vehicles if we allow that. And air really begins to dominate, potentially at very long distances, but not necessarily at the shorter. So that's the purple bar there. You see air starting to pick up and really compete at the 500 mark, whereas it used to compete at the 500 mark. So that's 500 miles versus 2,500 miles of distance. And using, I guess this is probably the same here, this a little bit. So this is interesting to me. I think we're missing the, this is 2,000 to 7,500, excuse me. So the axes end at the same place, but they pick up at a different number at 2,000 here on the lower right. So using those same assumptions I talked about earlier, we're seeing, a big, we couldn't have any AVs before we added them, but maybe 50% market penetration, 5% more distance traveled by cars, whether they're self-driving or human-driven, and 12% more at the 500 plus mile mark, whereas airlines are losing about 50% of their travelers in both those markets. And of course, air was dominant and very big for this higher distance market, and again, still losing about half of that market in-person tours and also in vehicle miles, or I guess, seat miles in this case. But for the cars, it was about a 10% reduction in total highway, or increase, excuse me, in total highway. So that affects, our pavement engineers, that affects our energy and our carbon footprints and emissions and air quality and all these things. But I think losing air is going to be helpful because this is a pretty energy intensive mode, lifting people up into the air and taking them very long distances because they're going 400 miles an hour. So they can spend a lot of carbon really quickly once they get up in the air. And as I mentioned earlier, air starts to pick up right around the 500 mile mark if we're looking at conventional vehicles, and that shifts to maybe 2,500, where it starts to be competitive once you add in the self-driving option. You can look at it state by state. So we did. It looks like Texas was pretty typical, around that 10% mark, but Utah, Kansas, Wyoming had more than average. And so it's a complex choice process. It's a lot to model, whether you're going to travel with somebody. If you do, then you often want to go by car because the marginal cost of adding a person to a car is very low, whereas buying a ticket is high. And if you do fly, you're going to have to get a car at the other end of your trip or pay a lot of ground fees for taxis and that kind of thing. So big changes here coming to us for long distance, not just short distance travel. And when we talk about long distance, well, where should we put the charging stations? Because those batteries are expensive and they're heavy. And so most, my Tesla goes about 215 miles, all electric. And then we have to charge it for maybe 6 to 8 hours at home, or maybe 45 minutes at a supercharging station. And so there might be about 45 electric vehicles for every fast charging outlet right now. And the ratio of EVs to fast charger, might be 6 times bigger than it is to slow chargers, and the cost of installing these DC fast charging level 3 stations is tens of thousands of dollars. So it's a big decision. And of course, buying the vehicle is also a big decision. Are you going to put 400 miles on that battery, or are you going to go with a relatively inexpensive short range city version of that vehicle? And so, 400 miles is the typical range. My Prius goes 500 miles on one tank of gas, but most vehicles are designed to have about 400. So it's a big, expensive decision. And we went ahead and said, okay, what if you're allowed to place 50 versus 100 versus 150, all the way up to 250 of these fast charging stations? And what if you have vehicles that only go about 60 versus 100, 200, all the way up to 300 miles of all electric range? So where should we put these charging stations to try to maximize the completion of all of our long distance trip data? And that's that same data I was talking about earlier that we got from the FHWA. So it's all trips over 50 miles on the ground, not flights. And we also take into account in some of the scenarios that Tesla has already invested a great deal. And this is why Elon was sleeping on the floor for a few years. He's now an incredible billionaire, but he put a lot of his money or his company's money into those charging stations. And so it's an interesting balance of range on each of the vehicle or stations, adding more stations versus adding more range. Who pays and how do you recover that money? So we used that 2010 data that we got from the FHWA, and it was almost a billion automobile trips per year that qualified. And then we had to find the shortest path distances between all of those zones I talked about earlier. And we clustered them because there were so many NUMAs that the network was extremely painful. And when you have to put integer, optimization decisions across all these nodes, it just is tremendous. And we were doing this on supercomputers, supercomputers that we have here at Texas, but it was still a very long solution time. So here's what that looks like when you've got 196 of these clustered endpoints. You can see big travel. I guess, I don't know if this is Miami and maybe Orlando here. We've got maybe San Antonio and Dallas, and we've got Philadelphia and Boston and New York up here. And I guess Sacramento, San Francisco, and LA, San Diego. Those are some of the big flows for road trips in this nation. And so we definitely wanted those things connected. So this is the Simplified US Network with just under 1,000 nodes and about 60 miles distance between them. And 196 origins versus destinations. So maybe 100,000 trip pairs. And it's a constrained maximization problem. It's got that integer choice of which nodes to park those 100 or 150 or 200 charging stations at. And we ended up seeing, well, as we increased the number of charging stations and we increased the range of the vehicles, you could see how quickly we got to supporting 100% or nearly 100% of those trips. And you can look at the number of trips served or the percentage of trips served. And so with just 100 stations and a 200-mile range vehicle, which is pretty typical of what I think a lot of Americans may be willing to pay for, you're getting above 90% trip completion. So you may have to stop every 4 hours for 30 minutes to refill that battery, but most people want to get out of their cars every 4 hours anyway to stretch their legs and get some food and that kind of thing. When we added 200 stations, when we could go down to 150-mile range vehicle to serve the same number of LD or long distance trips. So the range was more helpful than the stations. And, the percent VMT served looks very similar in terms of these percentages, but this now on the y-axis is the total vehicle miles rather than the total or the percentage of trips that are being served. And so very similar, but somewhat lower shares if we're looking at it in terms of VMT or vehicle kilometers traveled, whichever unit you prefer. Here's an example of where those 50 stations would be if we had 150-mile range vehicles, and if we had just 100, or if we had 100 stations, where would you add them? So here's Illinois, you guys, in case you're wondering. I'm not sure Urbana's in a great place when we have only 50 stations, but you're doing okay once we add 100 stations. So pretty good population density, and I think our nation's 4th most populous state. 150 stations, 200 stations. You see still very little happening here in this area of the nation. Very few trips, I guess, going through those states. You see more when we get to 250 stations. And of course, Tesla's probably over 400 stations now. So when we were writing this paper, they had 368 stations planned. And these are supercharging stations, not their urban stations. And we were asking, well, where, given those, where should we add 100 new supercharging stations if we wanted to help Tesla with its network? So it's a tricky algorithm. It's required supercomputing, but it's very, very relevant and very valuable. And I sure wish the Department of Energy would ask us for our algorithms. We do partner with them on certain things, and California is pretty key because of the high rate of adoption in California. And of course, Tesla is very important, but they will charge a high price if you are a different manufacturer and you want to buy into that big, thoughtful investment that they've been making for a decade now. So more than doubling of completion rates. And so Tesla's choices may not be optimal for all US trip making, but they were focused on their California buyers. And now they're, of course, coming to Austin. They've got a big gigafactory being built right now. And at some point, they might build a gigafactory here in the Twin Cities, Minneapolis and St. Paul. This is a 7-county region. And they have about 10 million person trips per day happening across that metropolitan planning organization's region. Back then, we were using MatSim, which is a non-proprietary software out of ETH, a technical university in Switzerland and I think France. So this says a lot of links, over 300,000 links, and I guess 131,000 nodes. There's a missing a K there. We focused on just serving those trips with shared autonomous vehicles, but not serving any freight. So we ignored trips that left the region or came from outside the region, and we ignored trucks in this particular setting. And so one of the big questions when you have shared autonomous vehicle fleets is, what if they overwhelm your curbs? And so what we did is we looked at those very busy curbs, the curbs that would have over 400 pickups or drop-offs a day. And we placed parking lots nearby to handle them. And with a fair amount of vehicle capacity, so they didn't ever actually fill up. We just wanted to make sure they were big enough. And so if you look at the 7 counties, you can see those 134 parking lots wherever they have their busiest curb locations. Some are downtown Minneapolis, some are downtown St. Paul, and then some are up here in the northwest part of that region. And so if you zoom in on the Twin Cities, this is Minneapolis and this is St. Paul on the right, you can see those stations a little bit better. And there's quite a few of them. So a lot of busy curbs in the downtown Minneapolis location. And the SAVs were stopping for passengers or whoever wanted to drop off or pick up. They had to quickly leave unless for some reason there were no spaces left at the closest 2 parking lots that we build for this fleet of shared autonomous vehicles. Then we allowed them to idle at the curb, but I'm not sure any ever had to do that over the 24-hour days that we were simulating. So we were expecting curb restrictions because it can get chaotic, just like at the airport, it can get chaotic. But we do expect those restrictions to generate more vehicle miles traveled by the fleet. And sure enough, we saw that not just occupied vehicle miles traveled, but also what we call empty. So that E stands for empty vehicle miles traveled because, generally they would be empty as they head to that parking lot or they come out of that parking lot to go serve a trip. It's just not as efficient as sitting still and waiting for the next call. And their work duration, so the hours that they were running each day, instead of 8 hours, they might have been running 9 hours. So they were having to stay busy about another 15% of the day. And the ride sharing, so DRS stands for dynamic ride sharing, that fell because they weren't as easily available. So some people, ended up having to head out by themselves. And so that probably increased wait times a little bit too, for sure. So they lowered that dynamic ride sharing, which was unfortunate. So the percentage, this is kind of interesting. I'm seeing like a 5% and 0.5%. So I have to ask Kaunan about this. One of these is probably a typo. And the wait times, like I said, did go up depending on the scenario. So we simulated a geofence for the entire 7 counties. So you could go to any origin or destination pair in those 7 counties. And then we drew lines around the Twin Cities. And when we did that, when we focused on just the Twin Cities and the area between them and allowed that to be our geofence, we were able to simulate more travelers. So it was a little more realistic for ride matching, which is what you want. If you, have a tool that can only simulate 5% of the travelers, you're not going to be able to get that intensity of demand in time and space that will allow you to put 2 or more people or travel parties into the same vehicle. So that we were able to do a higher share of travelers when we zoomed in on a smaller geofence. So each traveler in a region makes about 3 trips a day, maybe 4 trips. So a 1-to-5 ratio of SAVs to travelers. We didn't have a mode choice model in this particular setting. We made everybody in his 10% sample, let's say, take the SAVs. So they didn't have a choice. We didn't force them to share rides unless it was reasonable. So it didn't add to their travel time by more than 10%, let's say. And we were able to specify like 1 SAV for every 5 people, or maybe every 15 to 20 trips that day. And the empty vehicle mile traveled went up when we went down to this, or when we went, I guess, down to this, or I guess it didn't go up, it just averaged about 10%. So this may sound a little generous. 1 vehicle can serve just 20 trips a day. If you really push that fleet, you can get them to serve 30. And in some cases like Manhattan, where the trips are short, you can get them to serve 40 or 45 or even 50 person trips a day if the distances are short. But for a big region, a 1-to-5 is pretty generous because they end up doing like 300 miles of travel a day, which is a lot more than your vehicle and my vehicle would do each day. And depending on what scenario, they might be busy 4 hours a day or 9 hours a day. And personally, if this were my fleet, I'd want them busy for a full work day, and I might have them delivering pizzas in the middle of the night. So I might come up with some other uses for them during those low demand times a day. When we made 1 vehicle serve like 45 trips a day, it was harder on the fleet, and they actually ended up doing more empty driving because there weren't nearby vehicles to help. So we had to take vehicles from farther away and bring them to serve the calls that were coming in. And of course, their run times, how busy they were, increased, and the wait times increased for those people because there just was, a third the fleet size to serve the same number of trips. When we turned on ride sharing, so dynamic ride sharing between strangers, sort of like a little tiny bus that seats 4 people, the response times fell by about 10%. So that helps get people served faster when you let them share the vehicle. And the Twin Cities simulations, had more ride sharing and shorter wait times because the distances tend to be shorter in those settings. So the fleet is more intensely spread there. The empty vehicle mile traveled was mostly in neighborhoods that had a lower trip end density, and this can affect how you price these things, right? If a taxi driver has to go all the way out to the middle of nowhere to pick you up, he or she's doing a lot of dead heading, and so you're going to want to maybe price that differently. And most of the vehicle miles traveled, including the empty vehicle miles traveled, was happening on freeways and highways, which wouldn't be necessarily my expectation. You and I think, may do about half of our miles on freeways and highways, unless it's a long distance trip, then it'll be maybe 90% or more on a freeway or highway. So it is interesting to me that these SAVs are finding themselves on those kinds of facilities more than half the time. I'm sorry, I don't have the percent here. It was interesting also to me that the response times or the wait times, depending on the time of day and how busy the fleet was, they were similar across the neighborhoods. And so even though there was more empty vehicle miles traveled in those sort of rural zones, the response times were almost as good as they were near the core. The best response times, by the way, if you're trying to figure out where to locate your next residential unit, are downtown. So you can get picked up within 2 minutes regularly downtown. But once you leave the downtown, it tends to be about 5 minutes, maybe 7 minutes. And in the afternoon peak, it can be 10 to 15 minutes. So ride sharing is really important to make good use of that fleet during the afternoon peak period. That's the hardest time of day to serve. We also look at energy and emissions impacts. So in this case, Hao Non was taking like my Prius, I guess, and then he was taking maybe my Tesla. So I think my Tesla has 120 miles per gallon equivalent, and my Prius has about 50 mpg. And depending on which kind of fleet we use versus a 30 mile per gallon Camry, let's say, so it's a US sedan, we were saving 20 to 64% of energy on the operations. I don't think the embodied energy, once we add that in, it would be quite that big a savings for the battery electric Tesla. And then, it depends on the different species, but there's carbon monoxide, there's hydrocarbons, there's maybe some particulate matter and NOx. So depending on the emission species, and you can see these here, you can see the reductions depending on whether we used a hybrid vehicle, a battery electric vehicle like a Tesla, or we use that internal combustion engine. So relative to the conventional Camry at about 30 miles per gallon, you can see the drops in energy with the battery electric vehicle, of course, being best here. There are different emissions costs. So, not every species is equal. Like a carbon monoxide is not such a big deal these days, whereas particulate matter, especially fine particulate matter, is very dangerous, which is why I recommend none of you ever get a diesel vehicle, and don't let your family and friends get diesel. In fact, please go all electric for me. But yeah, these are the different cost implications. So this is a shared autonomous all electric vehicle. And you can see there's a fair amount of SO2 because we still have coal-fired power plants. And even though they go to Wyoming to get the low sulfur coal, it is still nasty stuff. And it produces that fine particulate matter that is killing 100,000 people in this country early every year. So people die about 5 years early because of compromised lungs on average in this country. So unfortunately, none of these scenarios is going to meet the Kyoto Protocol or anything that we need in the transportation sector to do our share to get to avoid more than a 1.5 degree Celsius warming. And so again, I know that it's very cold there in Urbana-Champaign, but I'm sure you agree with me that we really need to decarbonize and also get rid of that diesel. So other things we look at are just autonomous vehicles and their implications. They affect travel demand. They might give us better route choices, but they do allow new people to start taking more trips because they might not have a car or they may not be able to drive for various reasons. I don't expect 2-year-olds and 5-year-olds to get to go around in these vehicles, but certainly 15-year-olds and a lot of 16-year-olds that don't have licenses or don't have access to cars, and epileptics and elderly people who don't drive at night, they're going to be adding some demand. We've got the empty driving from those shared autonomous vehicle fleets. We've got the longer distance travel we talked about. That's all going to add up, not just in terms of VMT, but in terms of energy implications. We might get more efficient driving cycles, but we've got more power demand on the vehicle, so that requires more energy. We've got maybe faster travel, so some people are worried about the drag coefficients and the implications of going faster if we can get vehicles to speed up, and platoon, for example, thanks to vehicle-to-vehicle communications and driving, self-driving. We've got ride sharing that can be really helpful. And of course, maybe someday if you get enough vehicles that are fully automated, you can turn your intersections over to smart signals, but you have to watch out for the bicyclists and pedestrians because they can't hear the radar. So they can't tell what you want them to do. They can't jump into that intersection, run out of it exactly on the timing that you're asking the vehicles to do. But in those settings, you know, we might be able to save some energy by getting people through those sources of delay much faster. The biggest place, though, that we are going to get the savings is making sure that these self-driving vehicles are all electric. And because they do have that higher power demand, we do expect them to be at least hybrid. So depending on how this goes down and hoping that nobody starts driving bigger vehicles, right? We're worried about people putting bathrooms and beds in these self-driving vehicles so they can just live far from their jobs and their schools and just sleep on the way to work or you know, the dentist, wherever they're headed. So we got to watch out for the vehicle size and keep it right sized and go all electric. And that will help. But again, it will not get us to the Kyoto Protocol. So if you're interested in these kinds of topics, you can just Google my crazy last name. And there's a whole section for autonomous vehicles and a whole section devoted to energy and emissions. So there's lots of electric vehicle papers there. Appreciate your time, and I look forward to your questions. Thank you.
Professor, thank you so much for your presentation. So now we're opening the question. If there's any question from the room.
I have a question, Denise.
Oh, yeah.
Thank you so much for coming here and not coming in person, but in spirit. and thank you for the informative presentation. I have a quick question. When you did the LCA or calculating the emission and you shared with us the parameters, is that just during the driving or that went beyond just the driving?
Yeah,
like,
I think
the whole
Haonan's
phases or just one?
Yeah, I think Haonan's numbers may have been operation phase only. So he was using moves. And from what we know about, you know, the Tesla fleet, they source very intelligently because that's the whole reason Elon went into electric vehicles and created Tesla, is because he's so concerned about the planet. But so they're very careful where they get their energy and where they make their investments to power their plants and mine their battery materials. But I think, you know, most battery electric vehicles over their lifetime are about half the emissions of the comparably sized conventional vehicle when you include all of that upstream energy and emissions implications. So I think it wouldn't fare quite as well once we brought that in. So I think now, instead of being like 90% from operating and 10% from manufacture, all electric vehicles are about 50-50 on those two sources of emissions and energy.
All right, thank you.
There's any questions?
I have a quick question.
Okay, there is one question from you.
Thank you for the really nice presentation. I just have a quick question for, let's say, an average consumer. So if I were an average consumer in Texas, and I want to buy a car, and if I'm not mistaken, 64% of the energy in Texas comes from natural gas and coal, right? So if I want to buy an electric car, I might be thinking, okay, my car is electric, but the grid is powered on mostly on coal and natural gas. So do you think that a prerequisite for you to make all these energy savings is overhauling the entire energy grid into renewables?
Yeah, so Texas, it already beats the conventional and it will get better over time. So one of the odd things is that if you buy a conventional vehicle, it's going to get dirtier over time. It's going to decay, and an all electric vehicle is going to get cleaner because your feedstocks are going to get cleaner, unless you move to, I don't know, China or something with that vehicle where there's still a fair amount of coal. But yeah, natural gas is certainly less carbon intensive than coal. So the split on the natural gas and the coal, or these sources of greenhouse gases, is important. I think the Austin grid is about 70% zero carbon now. So we have a rule in Texas where each power provider has to source its demand, and the Texas grid is probably just, gosh, as you suggested, maybe 45% zero carbon at this point in time. So that's nuclear and, you know, obviously hydro and air and solar. Those are all considered zero carbon. I think nuclear is maybe 20%. It used to be, and I would love to see nuclear go up, by the way. I think that's really, really smart and important, but it is taking forever to get nuclear plants built in this country. And so it's a hard road to follow.
Thank you.
And yeah, we have a paper on that in case you want to look at it. The numbers keep changing. So the vehicles keep getting cleaner that are all electric. The feedstocks keep getting cleaner as we retire coal here in Texas.
So Dr. Kockelman, actually, I have a question. So about the charging stations, you're modeling it using a Tesla, but I remember you model fast charging station and then place it across the US. So I was thinking that is it only, are you just modeling Tesla or how is going to be implement for the public's charging stations?
Yeah, no, Tesla owners are very well served. They have more than 400 supercharging stations now across this country. You can go anywhere. And I think you can go probably anywhere in Canada and get up to Alaska. Not sure about getting through Mexico, though, and heading down to Guatemala or something. So Tesla owners are very well served. But of course, a lot of people do not have Teslas. They're expensive vehicles, and that battery pack is expensive on any vehicle still. So that's why most Americans are still shying away. Is they're a little myopic. They think they're going to crash their vehicle and not be able to save all that money on maintenance and operating costs long term. But we just used Tesla as an example. We did all sorts of different range vehicles in that paper. So we started with a 60-mile range and we went up to just, I think, 250-mile range, maybe 300-mile range. So it was all sorts of vehicles, but we did assume one type of vehicle at a time, whereas we really have a mix here in the US. A lot of my neighbors have the 350 battery pack. I thought that was a waste of money, so I went with the 215-mile all-electric range Model 3, which is a rocket, by the way, guys. You're gonna love single pedal driving and your garages are gonna smell amazing. So these are part of the reason you want this vehicle. So save up.
There is a question from Zoom. Okay, there is a question from Zoom. So Lama, can you read it? No, Hazel is already there. Yes, he's there.
Yeah, I have a question. So I saw in the first part that you presented, the transit trips went down as the congestion everything got worse because all the vehicle miles traveled increased across Texas. And then what would be the reason for transit going down? And secondly, what do you think is the role of transit in this? I mean, my assumption is that in the road to a more sustainable future, transit would be increasingly more important. But it seems like here it doesn't highlight that, or doesn't use or leverage transit in any way. So what are your thoughts on transit in the post autonomous world?
Yeah, so everybody likes to think that transit is a sustainable mode, but those diesel buses are bad. And even the all-electric buses. So you're paying $300,000, maybe $400,000 for a vehicle. You probably have to buy 2 all-electric buses to take the place of one bus if you're, I guess, a conservative or risk-averse fleet owner. And then you have to change out, your energy sources. But that diesel is so bad that we really do need to electrify the bus fleet. And I'd like to see, a self-driving bus fleet because those drivers are so expensive. So we're spending a lot of money on the asset, spending a lot of money on the driver. And a lot of the time there's nobody in the bus except for the driver. So the average occupancy or the average passenger miles per bus mile in this country in service is 9, and it's probably less if you include all the empty deadheading bus miles that our bus fleets travel. And so that's not very good, right? If you could fill a car with 2 or 3 or 4 people, you can beat those emissions easily. So I would much rather see like a sort of door-to-door service rather than people waiting around to get their transit bus to come. And that's why you see so many people shifting from transit to the SAV, because it goes where you need it to go at the time you need it to go. and you can also switch to other modes. So we were hoping, this country really should make vehicle ownership a lot more expensive. Gas should have a tax of at least $2 per gallon. It's $1 per gallon for the military expenditures we spend in the Middle East to protect energy source, petroleum, which has been terrible policy for this country and, as it turns out, for the planet. So that's $1 per gallon right there. And then the other dollar per gallon is if you start pricing out all the emissions from that hazardous material. So gasoline should be a lot more expensive. Vehicle registration fees should also be tied to the size of the engine and everything like they are in Europe. If we want to go crazy, we could go ahead and do what Beijing does, which is a lottery for licenses to own a vehicle, or Shanghai and Singapore, which have an auction. So really, I think having smaller right-sized vehicles that turn off when they're not in use is much smarter than having this big bus running around almost empty most of the time. And that driver is on an 8-hour shift, so he just keeps driving, whereas we need to be able to turn those vehicles off. We need a smaller vehicle. And if you go to my website, you can find these papers about first mile, last mile use of SAVs to serve like train stations where we have big investments. That's an expensive thing to let disappear, especially in the Chicago area. And we also have how these vehicles would compete with buses in terms of the perturbations on the traffic. And I think Dr. Talibpour can tell you more about this, but these big whales coming in and out of the vehicle stream is really tough on the traffic. So having a smaller right-sized vehicle, self-driving, much more frequently is much better for the system. So I'd love to see the transit agencies take over these fleets operation and manage, provide, or at least vouchers. It's probably much smarter that the transit agency just gives vouchers to all of us, and we have congestion tolls, and we get these credits that we can use for these better modes, and including all electric bikes. And of course, conventional bikes. I love my conventional bike. But yeah, I think, it's a mix of modes, and the car should be a lot more expensive in this country, but I don't think our current transit vehicles are anything to crow about in terms of energy and cost effectiveness.
I do have one more question. Hello, Professor. Thank you for this great presentation. I just have a question regarding the rules and regulations. With the implementation of autonomous vehicles, how do you think the traffic rules and regulations will change? For example, in California, they are increasing the pavement marking thickness from 4 inch to 6 inch. But what else?
For self-driving vehicles, they're increasing the pavement thickness by 50%.
Yes.
Is that right?
Marker thickness, not the
No,
pavement,
pavement marking.
the marking thickness.
Oh, marking. At first I thought you said parking, and that's so interesting. So from 4 millimeters to 6 millimeters, or the
4 inches to 6 inches.
Okay, so the width. Okay, got it. So interesting. Yeah, I hadn't read about that, but that is like the number one thing. Like if we could change, it would be more visible lines on the road, and more visible curbs, I imagine. So I don't expect too much to change, quite honestly. I don't expect a bunch of narrow lanes, for example, because the trucks are still going to be wide things that you don't want near you, regardless of who's driving. And yeah, I think, those intersections aren't going to change for a long time, because you've got to be like at 95% penetration in the vehicle fleet. So until we outlaw human-driven vehicles, I don't think we can really change over a lot of the intersection signal patterns. And of course, anytime you have pedestrians and bicyclists going through that signal, it's got to revert to sort of a visible red and green. So yeah, I'm not expecting too much. I'd be curious if anybody else has any thoughts, but thank you for alerting me to the 4 to 6. That's interesting.